Lesson 10-2, Parabolas, Part 1. You learned about parabolas back in Algebra 2, except now we're going to go a little further in depth with parabolas as part of the conics unit. So first you need to know the definition of a parabola. And a parabola is the set of all points in a plane that are the same distance from a fixed line and a fixed point not on the line. So if you look here at the graphic off to the left, you'll see that here I have a parabola in blue, and I have the fixed point here, and I'll label it F so that you know that that's the fixed point. You also see a red line here. Well, we call that red line the directrix line, and that's what's considered the fixed line in the definition. And the fixed point is called the focus, and that's also in the definition. So if I were to draw a line, basically from the focus to the parabola, I would have some sort of distance, call it K. And then I would also have that same distance if I were to drop that point down to the directrix and have it meet at a 90-degree angle. That distance would also be K. I could have chosen there, or I could have drawn it from the focus to this point and then down, and the distance from here to here would also be the same. The distance from here to here would also be the same, and eventually the distance from the focus to your vertex and your vertex to the directrix line would also be the same. So the biggest point with the parabolas and what you're going to be doing next is that you need to remember the distance formula. So remember that you have your distance formula as d equals the square root of the difference of your x's squared plus the difference of your y's all squared. Okay, because that's going to come into play when you're trying to find the equations of the parabolas. So to write an equation for a graph that is the set of all points in the plane that are equidistant from the point f of 0, 0, 5 and the line y equals negative 5, you need to write the equation of it. So first what you want to do is you want to basically draw yourself a sketch so that you know what it should somewhat look like. And it doesn't have to be perfectly plotted, so it's just a sketch. So you have the point f0, it's 0, 5, so it should go here. And you have the line y equals negative 5, which would go here. And you know this is the point 0, 5. So you want to write the equation of the parabola. Well, to know the parabola, if you're going to draw it, the parabola should essentially open with that point inside of it. It's almost like Pac-Man. You can think of the parabola like Pac-Man's mouth, and it has to eat the point, so it has to eat the focus. And it should be running away from the directrix line. Okay, so when you're doing your graph, or when you're doing your equation, you want to basically think about distance. So you take the focus, and if you draw a line anywhere onto the parabola, you're going to have some distance. And let's call that point P that's on the parabola. And then you're going to draw another line from that point P down to the directrix line. Call that point Q where they intersect, and they meet at a 90-degree angle. Now you know what the ordered pair is for F. You don't know what the ordered pair is for P, so call that XY. For Q, you don't know the entire ordered pair, but you know half of it. You don't know what the X value is, but you do know what the Y value is. So Q's ordered pair would be the ordered pair X, comma, negative 5. So now you need to just remember your distance formula in the definition of a parabola. You know that the distance from F to P should equal the distance from P to Q. So think of your distance formula, and you're going to have the distance of F to P equal to the distance of P to Q. So now actually substitute in for your X's and your Y's. Here from F to P, we know that the first X is 0, and the second X is X from P, and the first Y from F is 5, and the Y from P is just Y. Do the same for the distance from P to Q. So now you've substituted in for all of your X's and Y's. Now when you have your equation, you notice that there's square roots on both sides. Square roots are messy, you usually don't want to deal with them, so instead get rid of the square roots by squaring both sides of the equation. Remember, what you do to one side, you also have to do to the other. When you square both sides, the square root symbol essentially goes away. So now that the square root symbol is gone, now you can do your squaring of your polynomials. Okay, remember you're not squaring everything inside the parentheses. You actually have to do your binomial times a binomial. So make sure you here I simplified the 0 minus x all squared to just negative x, and I simplified the x minus x on the other side to 0. And then you just have to make sure that you essentially do out your FOIL or your distributive property so that you make sure that you aren't just squaring each part of the inside the parentheses. So now do out your multiplication. Combine like terms on both sides. And now you want to basically you want to get all of your y's on one side and your x's on the other. So if you go back and you look at our picture, we have a parabola that opens up. So it should say y equals something x squared. So now let's move our y's onto one side. We subtract y squared from both sides and add 10y, so some things end up canceling. Subtract your constant from the left, and then divide by 20, and you end up with your equation as y equals x squared over 20 for the equation of your parabola. So if you have another one where you have to write the equation for the graph that is a set of all points in a plane equidistant from the point f0, negative 4, and y equals positive 4, you want to basically do the same thing we did on the previous page. So I'm going to go through and solve the problem, but you should pause the video now and try to do this one yourself and then check your work with mine. So here I've drawn a sketch of the picture to help myself to know that, oh look, the parabola opens down, so my a value of the parabola should be a negative sign, and it should say y equals something x squared. Here's everything substituted into the distance formula, and then get rid of the square roots. Now I've gone through, gotten rid of the square root, I've squared all of the parts of the polynomials. After doing all the multiplication, make sure you combine like terms, and then you need to gather everything that is common on one side of the equation. So now I'm left with x squared equals negative 16y, divide by negative 16. So you're going to be left with negative x squared over 16 equals y, or you can think of it as y equals negative 1 over 16 times x squared. Okay, your parabola opened down, so this number here in front of the x squared should be a negative number. So you've seen some parabolas before in a previous chapter where you've seen ones that open up and ones that open down. Okay, certain properties of those parabolas that you should know about. They are both in the form y equals ax squared. Depending on how the parabola opens determines what the value of a is. Remember, if the parabola opens up, a should be greater than 0. If it opens down, a should be less than 0. Other things that you should know about. The focus when it opens up is inside the parabola here. When it opens down, the focus is here inside the parabola. Remember, it's almost like the parabola is eating that point, which is the focus, F. Some other things that you should know, we call the focus is at the point 0, C, and we'll get into what C means in just a few minutes. And here the focus is at 0, negative C because it's at a negative number. The directrix line will always be a horizontal line when you have a parabola that opens up or down, and it will be here or it will be up here with the second one. It's always going to be a y equals a number, and it should have also a c with it, and it's going to basically be the opposite sign of what your focus was. So here when it opened on the left, you had 0, opened up, you had 0, c, so your directrix line should be y equals negative c. When it opens down, it should be y equals positive c because the focus was negative c. So where does c come from? C is important because you also had learned before that c is essentially the distance from the focus to, is the distance from the vertex to the focus, It's from the focus to the vertex or the vertex to the focus. So here is the distance c. Well, yet earlier in this video, I also showed you that that distance from any point on the parabola to both the focus and to the directrix should also be equal. Okay, so this part here should be C, and then the distance from the vertex down to the directrix would be also C. Or here from the focus up to this vertex would be the distance C, or from the vertex all the way to the directrix line would also be C. Okay, so C, where does it come from? C comes from using A from your equation. In order to get C, you have to know that the distance, or absolute value of A, equals 1 over 4C. Okay, and that's going to come into play in a few minutes when you're looking at one of the next slides. So make sure you just remember that the absolute value of A equals 1 over 4C. Other types of parabolas that you've never seen before in this textbook are parabolas that open to the left and to the right. So here it's going to be a little different when you're looking at your parabolas. Your equations are going to be somewhat the same but somewhat new, where instead your equation is going to be x equals a times y squared. Okay, here on the left one, you're going to see a parabola that opens to the right. It's eating the focus, so your a in this case should be greater than 0. Your c is going to end up having to deal with, again, the distance from your vertex to your focus, and you're going to have a focus instead at the point c, 0. Your directrix here would then also be to the left of your vertex, and your directrix this time is going to say x equals some number, and that number is going to be negative c. Okay, the other one, your a will be less than 0. Your focus instead should be somewhere inside the parabola, so that's going to be at a negative number, so it's going to be negative c, 0. And your directrix should be instead out here in your positive area, so it's going to end up being x equals c. Okay, so just notice that the signs are different with the focus and the directrix. So they're going to be the same number, they're just going to have opposite signs. And that when your parabola opens left to right, you have to make sure that you have a directrix that is in x equals, which is also the equation of your parabola. So, how do you write an equation of a parabola with a vertex at the origin and a focus at 3, 0? So when you want to write the equation of a parabola, you should either have it as x equals something y squared, so x equals ay squared, or it should be y equals ax squared, depending on how it opens. So draw a sketch. If you have a focus at 3, 0, here is where your focus is. Well, that means then that your parabola must open, because it should eat the focus. It should open to the right. That also means then that your directrix is here somewhere. Okay, so in order to write that, you want to remember that your distance from your vertex to your focus is your term c. So think back to when I told you to remember that the absolute value of a equals 1 over 4c. You could write the equation, either one of these here, x equals ay squared or y equals ax squared. If you knew what a equals, you would be all set. But we don't. However, we do know that the distance from the focus to the vertex is c. And in this case, since the focus is 3, 0, our c value, or the distance, is going to equal 3, because my vertex is at the origin. So to find out what a is, we do the absolute value of a equals 1 over 4 times 3. So we get the absolute value of a equals 1 over 12. So then we would know that a must have something to do with 1/12. So now we have to think, do we want a to be positive or do we want a to be negative? And that all depends on how the parabola is opening. Since the parabola is opening to the right, a should be a positive number. Since it's also opening to the right, we know that we're not going to use y equals ax squared. Instead, we are going to use x equals a y squared. So just substitute in the a into that general form, and you end up with x equals 1/12 times y squared. And a should be positive because it opens to the right. And there's your final answer.